Great, I'd like to welcome you to Containerless in the Cloud. Today I'll be talking about Amazon Lambda. Just out of curiosity, how many of you have used Lambda before or looked at it? Okay, a couple. Okay, so in terms of title of the presentation is Containerless in the Cloud, and by containers I mean the traditional Java containers, WebLogic, Tomcat, Glassfish, etc. So we're going to be looking at, so for the last 20 years, this is how we've developed our applications, is written code, deployed these, set these up on computers or servers, and that's how we built our infrastructure and deployed our applications. So Amazon Lambda fundamentally changes this equation. And so, this is, if we looked at how we traditionally would have deployed up in the cloud Java EE applications and Java code up in the cloud, we would have set up our container on an EC2 instances on a VPC, load balanced a couple of machines, set up a database, etc., run our JMS server up there. So this is the way we traditionally have done things in the past, but that is changing. So with containers, we have multiple levels of lock-in. So you have a language lock-in, you have a toolchain lock-in, and you have an ecosystem lock-in. So if you go with Java EE you're locked into the Java languages or one of the Java languages on the platform. You're locked into a specific toolchain, that being Java with their IDEs and development tools and build tools, and also an ecosystem of third-party libraries. So if you're writing an application on Java, you can't go out there and necessarily use a JavaScript library, right, for part of your application. That would be kind of hard to integrate. So Amazon Lambda changes that. Although this is a little premature, RAP app servers, not quite yet, as we'll see. It doesn't solve all of the problems, but it's pretty close, and Amazon Lambda is definitely changing how we will be writing and deploying code going forward. So the drawbacks of a container, they're overkill for many types of applications, hence the popularity of Tomcat. They're hard to automatically scale. You have to do all of the scaling yourself, right? So you have to deploy multiple instances, set up load balancers. If your application is being used on more than one continent, you have to get it set up in a data center on that continent. Otherwise, you have to deal with latency and performance issues. You have complex programming models and can end up with, large, complicated, highly coupled applications. Depending upon which app container you went with, you can end up with maintenance contracts. That can be a significant investment. And then there's also significant skills investment in terms of security, configuration, and the technology stack. After all, you can't just download WebLogic, deploy it up on a server, and turn it loose on the world, right? You have to actually tune it, set it up properly. So there's a lot of work that goes on to, just getting an application up and running on the internet and making sure that it's hack-proof and reliable, etc. So using traditional containers requires servers, data centers, the software, monitoring tools. You have to actually know what's going on. Are you running out of heap? Are your JMS messages backing up? You have to invest in test environments because obviously you don't test live, although usually that's not a good idea. You need IT support. Service contracts, depending upon what type of application server you've purchased or what you're using. Data replication and policies, so that if your application is dealing with confidential data, there's rules as to where you can move that data. Between countries, there's certain blocks of data that you can't move out of certain countries, and you have to take that into account when you're developing your application, right? And then there's also the necessary approvals, so that if you're not running in a virtualized cloud environment, you have to get approval from IT to go buy servers for a test environment. You have to go grovel for those types of things, right? So those are the challenges with using traditional containers. And so, I challenge you for using the traditional containers to develop a web and mobile application that has registration and authentication using OAuth, uses HTTPS by default, because most mobile applications, if you're communicating with the back-end server, they don't allow you to do HTTP. So if you've written test like an application on iOS, Apple is not going to let you deploy an application that is making RESTful server calls using HTTP. You'll have to hop through some hoops and they may actually not allow you to actually deploy it to the App Store. SMS notifications, you forgot your password, sends you a message saying, okay, here's the link to reset it. RESTful endpoints that are scalable so that, you deploy your mobile application, thousands of people start downloading it. Now you need to have load balancers, you need to have infrastructure set up to handle the people that are using it. Imagine if your app turns out to be the next Pokemon Go, right? Suddenly everybody's downloading it, and your two server setup is can't quite handle it. And then you have to write native code for both iOS and Android in order to tie into your server code and to communicate with your server code. And then on top of that, you have to deal with versioning, right? Versioning your API because your application will go through different revisions, and also real-time monitorings. What's going on with your application. So if you're doing the traditional container approach, these are all the challenges to getting your application written and out the door. They're not actually necessarily part of the problem domain that you're trying to solve. If you're writing a game, you want to be focusing on the game, not all of this. And that's where Amazon Lambda and the Amazon Web Services comes into play. So all of these problems are infrastructure and services that are peripheral to what your application actually does. Okay, so that's where Lambda comes in. So Lambda is microservices without the application server on the back end. We're going to be able to deploy code and then consume other Amazon services without actually having to go out and set up servers or do any basic any of the traditional configuration that you had to deal with in the past. And so this is actually quite revolutionary. So in terms of the deployment model with AWS, you write your code, you deploy it, and you run it. There is no, there's no, request from IT for server resources on the back end. You don't have to deal with all the traditional setup stuff that I've mentioned thus far. So this is the Amazon platform, and every time I log in, they've added another couple of icons with another couple of features to it, so it is practically impossible to actually keep up. And if you know which ones they've added in the last couple of months, you can probably tell when I took this screenshot, because every time I generate this slide, I have to go out there and retake the screenshot. So Amazon provides a plethora of services up there that you can leverage from your application. We're going to look at a couple of those. So the one we're focusing on today with the presentation is Amazon Lambda, but we're actually going to use some of the other services to build applications. So Lambda Basics, for those of you that aren't familiar with it, are Lambda code is stateless. You can it's not Lambda functions in Java, so it's kind of a similar idea but different. The code is stateless. It executes in response to an event. You're coding it specifically for AWS. You're uploading it directly to AWS. You're either pasting the code in or you're uploading it to something called an S3 bucket, which is basically a storage space up on Amazon. The code is fully managed by AWS. They scale it automatically, which means that as invocations come in, Amazon fires up additional instances of that code, right? So the block of code that we're going to upload it once, and then based upon its usage, Amazon is going to instantiate it for us. So if 5 million, gets 5 million hits, Amazon will fire up X number of instances to service those hits. We don't have to deal with any of that scalability. It executes in an isolated environment, meaning that we don't have to worry about whether that environment is clean or not, or conflicting with another application. Instances may be reused, so it'll actually keep them warm for a while, so that if there's some initialization code or something like that, if the service is getting frequently called, it's not going to reinstantiate it every time somebody calls in. In the case of a Java function, it's not going to restart the JVM for each invocation. And you can make no assumptions about the running environment, so you can't assume that certain files, are there. If you can access the file system, you can't make any assumptions about what's in that environment, or things that you've left there. And then the real power of Amazon comes from, the real power of Lambda comes from Lambda plus the AWS ecosystem and all their other features, all the other services that it provides. So the programming model for Amazon Lambda, and we'll see a code sample shortly. You have your handler, which is a function, AWS Lambda function that that Lambda calls to start execution of your Lambda function. You have it passes in a context, which is basically an object that gives you ability to interact with the AWS Lambda infrastructure for doing things like logging. You have logging statements, which are written to CloudWatch, and then there is exceptions. So there's you have the ability to have errors communicated back in the event of a failure. Okay. So the handler invocation, it is asynchronous. So it's asynchronous if you're working with S3, SNS, or DynamoDB, and I'll talk about each of those services in a second. And it is the invocation is synchronous in the event of a call from the AWS console or the API gateway. The API gateway being the web services front end, which allows you to create web services to go on to your to invoke your Lambda function. Okay. So security for Lambda, security is provided by identity and access management. So you don't have to handle dealing with security, or coding your own security infrastructure, building it up. Lambda functions can start threads, access disk, access other AWS services from your function, so you can do just about anything. You can do quite a few things. The default safety threshold is 100 concurrent executions per region, and they can scale that up. But that's basically to, I guess, try to keep a lid on on your billing. You contact them if you want that extended. And then external libraries should be bundled with your Lambda function, and AWS will attempt to invoke your Lambda function 3 times in the event of a failure. So if it fails, they'll try to invoke it again and try to invoke it again for you. And one of the most dangerous things with like that concurrent execution is because you're billed for usage, although it's extremely cheap. If you have a runaway script that charge up a bill, you have to be careful because you're being billed for your usage of the services. Right. So the use cases, so S3 being the simple data storage, S3 plus Lambda. So an image processing filter document. So every time an image or a graphic file is uploaded to S3, S3 can send an event to your Lambda function, and your Lambda function does processing on that image. Say it scales it down for a thumbnail or something like that, or does some type of image processing on it. Kinesis plus Lambda, so Kinesis is dealing with large data streams, so doing something with transaction processing or auditing. SMS plus Lambda, alarm response, auditing, server event processing. DynamoDB, which is their Amazon database. So basically, every time a record gets inserted into DynamoDB, you can have a callback that tells you that a record was inserted so that you can do some processing on it, data validation or something like that. And then Alexa plus Lambda, you can easily build basically Alexa-enabled services so that you can talk to Alexa and it will invoke a code up on Amazon to do something for you. So the execution environment, these are the AMIs. AMIs are being the basically identifiers for the virtual machines. So you can actually, if you want to see what's on those VMs, you can actually instantiate, create an instance and go look at it. But these are the different AMIs for the different regions that they have set up. In terms of the runtime, you have, there's three different for writing code. For Lambda, you can write it using Java. So currently for Node.js, they're 4.3.2, Java 8, which is the Open JDK, not the official Sun distribution, the one that you download from Sun, and then Python 2.7. And today we'll be looking at both the Node.js and Java Lambda functions.
Why do you have Node version 0?
That's actually one of the versions that they support. So I don't know why I guess they must have some applications that depend upon it, but that's one of the ones that they have. One of the choices that you have when you deploy a function. In terms of the execution environment for Node.js, they provide an image library, a JavaScript image library pre-installed for you. And then they provide an SDK, a JavaScript SDK for you to use, which has a bunch of features associated with it. There's also an AWS SDK for Python. For Java, they have no additional libraries installed for you. Now, because you can write Lambda functions in 3 different languages, that means that when you're developing your application up in the cloud, you can use all 3 of these different languages and technology stacks for building your applications. So if you're deploying to a Java EE app server right now, you're limited to writing your code in Java and the libraries that come with Java. With Amazon Lambda, you could write some functionality in Java, you could write some functionality in JavaScript, or some functionality in Python, taking advantages of the strengths of each one of those, right? So that's gives you a powerful new way to build applications. So the event sources, as I've kind of already touched upon for AWS, are Amazon S3, Kinesis, DynamoDB, CloudTrail, which is basically like a logging SNS, API Gateway, which is HTTPS. You can also have custom app sources, for example, Android, although I haven't really used that. And you can also kick off Amazon Lambda functions on like a periodic basis, like you want this code to run every so often. Okay, timed intervals. Lambda functions, by default, they support versioning. When you deploy a Lambda function, it's basically the latest version. There's built-in versioning into the Amazon services, so you can deploy a new version of a Amazon Lambda function and set it up. So there's support for versioning. So it's not just you deploy that and that's the late it overwrites the previous one. Term that if you're going through the documentation will come across in quite a few places. Will ask you for the Amazon resource number, which uniquely identifies an Amazon resource. So for every Amazon Lambda function, there is a unique ARN for it. And then for each Lambda function, there are 2 ARNs associated with it. So one is the fully qualified one, which has the version information, and then the other one, the unqualified, which I believe goes to the most recent versions. Okay. In terms of pricing, the first 1,000,000 requests are free. So if you think about that, if your Amazon function is handling web service calls, the first 1,000,000 invocations, first 1,000,000 calls of your web service are free. They charge a duration of, I don't even know, a really small amount per gigabyte second used. And then the free tier is 1,000,000 requests at 400,000 gigabyte seconds. There's actually apps up there that will help you calculate to figure out how much it's going to cost you. Thus far, in all of my playing with it, I've yet to run up any sort of bill. I don't think I've ever been charged yet for using Amazon Lambda for the prototypes that I've built personally. As long as you don't put it in a script with max int on it, I think you're okay. So the pricing, and it seems like the prices always goes down. So this is an easy way to get your application up and running. If you're developing a mobile application, you need a back end, you need web services on the back end. The cost here is relatively trivial compared to the cost of buying a server, right?
Can you explain the gigabyte second notion?
Gigabyte per second. I believe that's used. That's data. I think that's data, but I think that's data ties into data transfer.
Also has something to do with the CPU execution.
Yeah. Yeah. Yeah, and that's where the calculators come in handy to try and figure out how you're going to actually scale it depending upon your expected load. So the real power of Amazon Lambda. S3 is the cloud storage, DynamoDB is the fully managed. SNS is a simple notification with a push messaging service. SQS is their simple queue, which is distributed queue messaging service. Kinesis is a service to collect and process large streams of data, records in real time. And then finally, Cognito, which is user authentication and management. So Cognito allows you to tie your application, say, into authentication, Facebook, for instance, or your own federated database of users. So you don't have to deal with writing the code to manage the users, to authenticate them, to handle the tokens, all of that. You don't have to do any of this. In fact, with Amazon Cognito, they'll even give you a block of code that you can download and put into your mobile app, so that the user can, and it'll give it a token that you then on Lambda invocations. So that takes care, and that ties in with the identity and access management, so that you don't have to worry about having one of your web services, and people are able to just pass in an ID and get. So in terms of S3, just a little bit of overview of each one. Features are it's basically data storage. It's secure, highly scalable object store. The data storage is in regions. You can access it via the web. The typical uses for this are backups, data analytics. You can host static websites on it, and also application data storage. And how this ties into Amazon Lambda, when you add a record to S3, you can set up basically a connection using their wizard between S3 and Lambda, so that it calls your code when a new object gets inserted or updated, etc. So S3, the data is stored in buckets. Each bucket has a name. That's just some basic information about the naming conventions for Amazon Lambda. For S3 buckets, and you go through their UI and you can create buckets. The nice thing about all the Amazon services is that everything is exposed. There's an API for everything, right? So there's RESTful endpoints for everything. They have an SDK that you can use, command line tools. Everything in the Amazon ecosystem is an API. So DynamoDB is the non-relational database. There's no limit on throughput or storage. They do data replication across regions, integrates with their Elasticsearch, ties into identity and access management, and the integration with Amazon Lambda is every time a record is inserted into DynamoDB, you get a callback. So from Amazon Lambda, you can be inserting data into DynamoDB, and you can be, as records are inserted, you could process them. SNS, publish subscribe messaging service. Messages are stored redundantly across multiple servers and data centers. We've got several different ways of receiving message notifications, including Amazon Lambda. And so when a new message gets published to SNS, your Lambda function gets invoked. And then SQS is a fast and reliable queuing system. Messages are stored across servers. This one is actually not integrated with Amazon Lambda at last check. Although you can tie it to SNS to get your messages to Lambda. Amazon Kinesis, this is a service for storing and processing large streams of data in real time. It's meant for processing terabytes of data. So this one integrates with Amazon Elasticsearch and also integrates with process data feeds from Amazon Kinesis. And so and then finally the Cognito, which I've mentioned, is the user and identity access management. So you can tie in and give if you're developing an application, you can seamlessly tie in without having to do any extra work to tie into Google and Facebook. If you've ever tried to set up, OAuth, set up basically an OAuth setup where somebody signs into your sites and it logs them into Amazon and Google, that's quite a bit. Can be kind of tricky to do. So it's taken care of for you, and you can also have custom identity and user pools. And they have the capability to sync functionality and synchronize user profile data across multiple devices. There's a whole bunch of features that come with this. So if you're looking to develop a mobile application, you want to allow your users to log in. You don't want to have them, you want to have them log in using their Facebook accounts. You can easily get that up and running with Amazon Lambda and Cognito. So as an example, mobile architecture. The API gateway is their web services front end, which I'll demo in a second. But in this case here, we have a mobile application that goes through the API gateway, Lambda and Cognito to do the identity and access management. And then once you're authenticated, then it can make calls to talk to Lambda and to put data into a DynamoDB. And of course, that last one, once the user is authenticated, the Amazon infrastructure is making sure that the user is allowed to do that, that they're allowed to talk to that web service, and that that web service is allowed to, and that Amazon Lambda function is allowed to talk to the DynamoDB given the user that has logged in, right? Then in terms of Lambda functions, you've got data centers around the world, which makes it easy because Amazon is running your code hopefully closer to the users. I know that they've been rolling out, off the top of my head, I don't remember which data centers don't have Amazon Lambda. I think they pretty much all have them right now. But theoretically, you don't know where your Amazon Lambda function is running, so it's running hopefully close to one of the users. So Java EE versus AWS Lambda. So the nice thing with Java EE is that it's a standard with several implementation, whereas the Amazon Lambda is the Amazon variant of this. Is an Amazon-specific technology. Google has their own competitor to Amazon Lambda. I think Microsoft now has one as well. And so at least all two of them are different. So AWS is a set of ready-to-use their queuing technology, the Elasticsearch. With Lambda, transactions, dependency injection. There's no equivalent between Java EE and the S3 bucket. So it's really Amazon's providing you with a bunch of services and then you're providing the code. But there's some trade-offs in terms of what you can do and what you can't do. Right, so there's no, distributed transactions. I read this off the queue, so only acknowledge. You don't have, like a distributed XA data source, for instance, so that if you fail to read the message off the queue and you want to roll back the database transaction, you don't have that type of stuff. So with that, I'm going to go over and I'm going to deploy back to my dashboard. So I'm going to create a new Lambda function. And the first page that it brings up, they have a bunch of recipes for you to get started. So you can actually go through, if you're learning Amazon Lambda for the first time, you can go through and try out some of the different recipes because they'll create boilerplate code that's kind of a starting point for you and kind of help you along the way. So I'm going to skip that. I'm going to just leave it as one that I invoke from the thing. So I'm going to do JDK IO. I will keep it as Node.js for the runtime. Let me grab my code from over here. Okay. So this is just a JavaScript function that's going to get invoked. I'll accept the default ones. I have an existing role set up on this account. And I can also run this as a part of a VPC, but I'm not going to timeout so that this function should execute within 3 seconds or it gets killed. So that looks good. I've created the function. So now I've deployed code to the cloud. I can actually go off and run that. So let me go back. Oops. Let me go back. And grab my code. So it's executing my function right now. Voila, we've executed code up. I've written the deployed code up in the cloud. Okay, and if we go through there, so as you can see, we can look at the configuration. We can see monitoring. They have a monitoring view that allows us to see, how many times we've invoked it, the duration. Were there any errors? Was there any throttling that happened? Triggers. What we can do now is we can add a trigger, which is some way of invoking it. Invoking, because right now we've just used the web console to do that. We can do the API gateway, which allows us to front end this JavaScript code that I just wrote with a web service. So it's going to, the resource name is going to be hello JDK. The method is going to be get. I'll put it into production. I'm going to turn off security so that anybody can open it. So please do not copy down the thing right now and script it. And there we go. Hello unidentified. So there, I've written code, I've deployed it, and I have a web service, and it's up and on the web. So if you were looking at doing this from a Java EE app container, you would have written a ton of, you would have written, a JAX-RS code. It handled, you've had to have written quite a bit of code in order to do this, right? Set up your app server, deploy it. Notice that this is using HTTPS. And we've got one URL. You can invoke this URL a million times. And it'll correctly handle load balancing. I don't have to go out there and set up additional servers, right? I'd have to look at that. So there we go. That's what it's provided by Amazon. So it's a valid certificate. I don't know off the top of my head. I haven't looked at that.
They should have a common name that all the people.
Common name.
Yeah, it's shared by all instances, I guess.
Yep. So we've now deployed a simple service up on so now we've deployed a simple JavaScript service up on Amazon. Let's look at doing it with Java. So with Java, the loading method directly with so it invokes a method, a handler function that you provide. The input type is the data or event or custom object that you want to process. The context is a Java object containing the execution environment information, and the output is a result if it's a synchronous call, so if it's a web service, etc. Implementing a standard interface provided by Amazon Lambda, so they have a request handler. So you have getters and setters with an OR constructor, and they automatically handle serialization. They do the serialization from Java objects back and forth to JSON for you. So on the context object that they pass in, you can get the memory limit in megabytes, the function name, the function version, the invoked ARN, a bunch of other, get the identity of the user that's invoking it. The logging API logger that they pass in is log4j. There's a Lambda appender. And so if you write anything to lambda-logger.log, it gets logged, or if you write anything to system.out and system.error, it also gets logged, and you can go up to CloudWatch and look at your logs. The dependencies, if you're creating, for doing this from Maven, this would be your Maven file where you're pulling in the various Amazon resources for doing it. The contents of your dependencies in your POM file. And this is a simple, the same exact Hello World example, except done using Java. And the request, so we've got a request that comes in, and the request object is this, and it's got two first name and a last name, a bunch of getters and setters, and what Amazon is doing for us is it's handling the Java to JSON and JSON back to Java serialization for us. So it's providing that infrastructure underneath the hood. I believe when I dug through and looked at what it was using Jackson underneath for doing the translation. When I went hunting for the libraries, I drilled down into their SDK and figured out that they were using Jackson for doing the mapping. Okay. And so with that, let me deploy the Java code. So here's the project over in NetBeans. We've got our hello world function right here. And so we can deploy this one. Once again, about the same way, so I'll skip this. Select Java 8. I believe I already have it up on Amazon S3.
Possible to auto deploy continuous deployment via Git or whatever?
I have to double check that. In the past, no. Now they may have introduced that. They've had a couple of tech summits where they announced new things. There was one a couple of weeks ago. I was not following along at the New York Tech Summit to see if they had introduced that feature yet. But that's one of the things that was missing from going from AWS code commit to Amazon Lambda. There were some people that had set up where you'd run an S3 with Jenkins that would allow you to use the Amazon APIs where you commit code to AWS code commit and then it would deploy it to Lambda. But as of last check, there was nothing. But they may have changed that. And so if I provide the URL, I've already uploaded it, so we wouldn't have to wait for it to upload and become available. Okay. Okay, so it's deployed. Now we can test it. Now I'm invoking it, basically doing the same thing that we did with the JavaScript one earlier. And there we go. It executed it. So I wrote a block of code, expanded it. We could do the same thing with adding a web service front end to it, then tie it into Cognito, so you have to log in using your Amazon account. Okay, and we can also go into LogWatch and look at the logs, to see what it was, the system.out.print lines or the logging statements that we put in. So we could track it there. Then we could write an Amazon Lambda function that processes the CloudWatch logs to tell us if anything went wrong. Right. So in terms of Java versus JavaScript, Hello World was billed at 200 milliseconds. We used 167. So it was billed at 200 milliseconds. We used up 167, so it was rounded up. We used 43 megs worth of memory for the Hello World with JavaScript. It executed in 2 milliseconds and used up 31 megs of RAM. So, this is a really basic test. This doesn't mean, depending upon what you're doing, there's going to be differences between them. But that's just kind of a baseline. That's where, with Amazon Lambda, you could write some code in Java versus other code in JavaScript or Python. And then with the APIs, which I'm not going to demo here, but you can actually go in with that Amazon API gateway, and you can generate binding code for your mobile device. Yes?
Well, on debugging, you might be sometimes be curious about if something is going wrong, and you might want to debug
That's a challenge. You're going to have to basically lean on the logging to find out what went wrong. Now there are approaches where you debug. There's approaches where there's kind of like test environments where people have created. There's documentation out there online for like creating your own ad hoc test environment for testing your Lambda functions to try to find out what goes wrong. But that is a problem or a challenge with doing it, is trying to debug it, because there's no way that you can connect from NetBeans to your Amazon Lambda function, because you don't know where it's going to execute. Okay. So anyway, so with this, you can take that Amazon API gateway, you can have it generate the iOS, the Objective-C code, Swift code to call your service. For the Cognito stuff, you can then have it also generate code for logging in, etc. So reasons to use Java EE. Java EE supports distributed transactions, long-running tasks. You wouldn't want to use Amazon Lambda for something like report generation because you pay for the amount of time that you use, and they will kill your thing if it exceeds it. So if the report takes a particular, if there's a lot of data and it takes a long time to generate the report, Amazon Lambda is going to kill it because it's time boxed, right? So anything that's compute intensive. Third-party dependencies, so integrating with legacy systems, WebSockets. So you're not going to be able to do WebSockets with Amazon Lambda at the moment. Although I think there's some ways of doing it with the of legal estimating and controlling costs, third-party licenses. So if you're using like a third-party library, which is node locked or something like that, and you're locked into the number of instances of that code that you can run on servers, right? For like a third-party commercial library. Trying to figure out how to deal with it up in Lambda is going to be tricky because you don't know how many instances Amazon is going to instantiate, what servers. There's no way to like set it up with with a license on it. And then regulatory requirements, snapshots for security instances, dealing with regulatory constraints. So then in terms of like an architecture for building an application, so this kind of looks a little bit like some of the Java EE diagrams where you've got your different layers, but you have the Amazon gateway. Underneath that you have the Lambda with the different languages that you could write your Lambda function in. Your EC2 instances, you can actually, if you're running within a VPC, you could call off to, say, a service that you wrote and are hosting on an EC2. So you could have your app server up in an EC2, you could have Lambda functions calling into that, etc. And then the different queuing technologies, the back end, the databases, and data storage. So this is kind of your stack for building an application on Amazon Lambda. So the challenges with dealing with Amazon Lambda are documentation. The documentation is in some cases kind of bad. Testing is a challenge. Debugging, as you mentioned before, can be very challenging. Tooling support, error handling, finding out what went wrong. And then lastly, the AWS code commit integration was lacking. I don't know if they fixed that recently. And then the Node.js version is also lagging, so it's not the most recent. So some best practices when dealing with Amazon Lambda: small archives containing code. So you don't want to include the entire application as a part of your Amazon Lambda function. You only want to include the code that's necessary for running the application. You want to minimize startup costs. So in some cases what people have done is they periodically invoke Lambda functions to keep them warm so that Amazon keeps an instance running so you don't have to deal with the cost of starting up a Amazon Lambda function. And then also monitoring logs for failures, writing some type of automated thing that keeps track of CloudWatch to find out if stuff is going wrong and to notify you if that happens. Some resources for working with Amazon Lambda. So the compute blog is a good place to start. The AWS forums. Just like the Java EE pet store, we have our equivalent pet store up on Amazon Lambda. The nice thing with this example is this example takes you through basically kind of a pseudo-real application in that it pulls in Amazon Cognito, API Gateway, Lambda, ties a bunch of different Amazon technologies together, and you can actually go through the tutorial and build that application. So it takes you through how to configure everything, deploy the application so that you can log in against Google or against a federated authentication system. And then lastly, there's the FAQs, which usually have some helpful information up there for you. Okay, and so with that, I'm going to, since I have a little bit of extra time, so I'll hop back to the code. So in addition to the code that we looked at, I also have an example of S3. So this is an example of you publish some data to Amazon S3 and you want to process it. So you upload a new object and you want to read out, the contents of this. This is just reading out the contents of the file. So this is just an example of integrating an Amazon Lambda function with S3. You receive an SNS event, so you can, just right now it's just going through and logging it. So this is the integration. So if you're writing a Amazon Lambda function for dealing with SMS. This is basically the boilerplate code that you'd start with, the same for the S3. Now, in terms of the dependencies, because right now, I mean, when you're using with Java, you usually include 3 million different jar files, right, with your builds. So what you want to do is actually build an Uber jar. You find it. So this is the shade plugin. And so basically what this is doing is this is taking all of your third-party libraries. So anything that I include as dependencies for my Amazon Lambda function will get wrapped up in that. So if I'm using like a JDBC driver to talk to an RDS instance, like an Oracle database or something like that, I would just put that, I'd declare that dependency in the POM. This plugin would then bundle it up in the jar file, so I'm only uploading one jar file for the service. Right? That's how it ends up on the class, and the Amazon Lambda invocation logic makes sure that everything ends up on the class path. Looks at the manifest. So that's it. Are there any questions?
How's the JSON mapped to the new class when using the API?
Yeah, so it's basically doing reflection underneath the hood. So it's looking at the attributes in the JSON and mapping them to attributes in the Java class. So if you notice, the case and everything lined up in my example. I'm digging through the Jackson library underneath the hood to do the mapping. Any other questions?
You talk about Java costs, and how long does it take when you get, I don't know, send a message to a queue, when does it process?
It doesn't take that long. You could probably have it up and running within the hour.
An hour? So if I send a message through a bus.
You mean how long does it take to process a message?
No, how long does it
You want to set you? So you want to?
does it pick up the message right away, or?
Yeah, basically, yeah. Yeah, so it's practically instantaneous. I thought you meant how long would it take you right now to create an Amazon account and actually deploy that. So probably less than an hour. You could have actually done the Hello World example as I went through the code right now and deployed that. The Amazon accounts, you don't have to set up a corporate account or anything like that. You can just go in there and log in with your credit card and be off and running with this. So there's no, sign-up fees or anything like that. That's the nice thing about this stuff. That's it. Okay, thank you.